students, we will continue the topic which we studied in the previous lecture. So if you recollect, in the previous lecture I had drawn this kind of figure where this is the path of motion of the object in this plane, and two positions I had taken P and P1, and position vector of these two positions are R and R1, right? And coordinate of this point is xy, and coordinate of this point P1 is x1, y1. So accordingly, R1 is equal to R1, this position vector is equal to the x1i plus y1j, and R vector is xi plus yj, and this is delta R, right? This is called the displacement. This called it displacement from P to P1. The object has moved from P to P1. So displacement is directly one straight line I have drawn from P to P1. That will be the displacement, and in the vector form it is given. This is the displacement vector. Means R plus delta R is equal to R1 by triangle law of vector addition. Accordingly, we found delta R. Up to this we had done. Suppose here's object has been moved from P to P1 in the duration delta t. So we will write if time taken by the object in moving from P to P1 is delta t. Suppose delta time it took from P to P1. Then velocity vector, of course it is average velocity we will be getting delta R upon, that is delta R vector upon delta t. Delta R upon delta t, that is the average velocity we are getting. So velocity vector I have written at the top one bar, it is called velocity vector bar, that denotes the average velocity, that is delta R vector plus delta R upon delta t. And what is delta R? That is delta xi plus delta yj divided by delta t. So that is velocity vector, that is the average velocity, that is delta x upon delta t, that is I plus delta y upon delta t j. So here delta x upon delta t, it is the magnitude of velocity along x-axis, because unit vector is along x-axis. So this is the magnitude of velocity along x-axis. Of course, it is average velocity. So we can write that is velocity vector, and that is the average, that is Vx average, right? I plus Vy average j. Whatever velocity we are getting, this is the magnitude of the velocity. Of course, it is the average velocity magnitude along x-axis. So that is Vx bar plus Vy bar. These are the average magnitudes of velocity along x-axis, and this is along y-axis respectively. So this is the important relation. So we will proceed further about the instantaneous velocity. Significance of instantaneous velocity, in the last lecture I told you, but geometrical interpretation of instantaneous velocity is required to be understood. My dear friends, remember, it's very important. Instantaneous means what? Instantaneous means at particular point, at particular time, whatever velocity and direction is there, that is called the instantaneous velocity. Whatever magnitude and direction we are getting at particular point and particular instant, suppose 5 seconds, 5th second, 7th second, 10th second, at that moment whatever is velocity, magnitude as well as direction, that is called the instantaneous velocity. Now we have got this relation, the delta R, that is displacement per unit time that is equal to delta x upon delta t I plus delta y upon delta t j. Now delta r upon delta t, that is the average velocity. This is the average magnitude along x-axis. This is the average magnitude along y-axis. Now as delta t approaches to 0, because you see from P to P1, it took delta t time. As delta t approaches to 0, means P1 will be closer, closer, closer and closer to P. So this object would have reached over here in some time delta t1, right? That delta t1 would have been less than the delta p over here, isn't it? So as it comes back, time taken from here to here, suppose certain time is there. So gradually time is increasing and is moving from P to P1, time is gradually increasing, means delta t is increasing. So as P1 is coming closer, means delta t will be lesser, lesser, lesser and lesser. So when P1 approaches to P, right, delta t becomes 0, means time from here to here becomes 0. It means when delta t approaches to 0, whatever this velocity we will be getting, that velocity will be at P. The geometrical interpretation of that I will tell you, but theoretically and with observation we can realize this thing. So if delta t is approaching to 0, so we write limit delta t approaches to 0, limit delta t tends to 0. In the terminology of calculus, the part of mathematics, means limit delta t approaches to 0, and this is delta r upon delta t we will write, and right side also we will write limit delta t approaches to 0 or tends to 0, it is delta x upon delta t I plus delta y upon delta t j. Right? I have taken, in mathematics we say we have taken limit on both the sides. A limit of what? This delta t, and that is approaching to 0. So on the left hand side we got this, and right hand side this. So this can further be separated. We can take the limit separately of these two quantities. So left hand side is limit delta t approaches to 0, delta r upon delta t, right? The delta r upon delta t. Here we can write limit delta t tends to 0, delta x upon delta t I plus limit delta t tends to 0, delta y upon delta t is j. This way we can write. We have separated the limit of both the terms. So this is called dr by dt, that is equal to, this is called dx upon dt, dx upon dt I plus dy by dt j. This dr by dt, dx by dt, dy by dt, these are the instantaneously, a particular time these quantities denote at particular instant. And this dr by dt in previous case, if you remember, it was average velocity, delta r upon delta t. Once we have taken delta t approaches to 0, this has been converted into instantaneous velocity, and it is simply denoted by v. In the previous case, I had put bar over it. That was the indication that this velocity is the average velocity. Now bar has been removed. Here it will be Vx simply I plus Vy j. And both, in all these cases, if you remember, we had written bar at the top of it, Vx bar I had written, Vy bar I had written. That was the average velocity and magnitude of average velocity along x-axis and y-axis. Here it is called the instantaneous velocity, means at particular place when the object is reaching what is velocity, that is given by this relation. So I think concept of instantaneous velocity and the average velocity is clear. Now I will give you geometrical interpretation of instantaneous velocity. I told you as P1 is reach approaching to P. So how the velocity is changing, magnitude and direction, that I will let you know geometrically. I will explain it. Now we will look at geometrical interpretation of instantaneous velocity. As I told you that this is the path along which the object is moving in this plane. I have selected two positions, P and P1. Between P and P1, it had taken some time to move from P to P1. Gradually, this position is brought closer and closer to P. Means delta T is being reduced. So at this position, P1 is delta R1. This way. This is the change, the position, and this is the displacement vector. P1 is the displacement vector. All these are displacements. Displacement vectors. These are displacement vectors, right? And we know the velocity of the object is along the displacement vector. So direction of velocity is this, parallel to R1, right? Direction of velocity is parallel to R1. Means, and for P2, this is the direction of velocity. For P3, this is the direction of velocity, right? For P4, this is the direction of velocity. Means direction is changing. These are velocity vector. Velocity vector. This is the velocity vector. For different displacements. Displacement is this. So velocity vector is parallel to this. This is the displacement. This is the direction of velocity. This is displacement. This is the direction of velocity. As the position changes, direction of displacement is changing, and accordingly, direction of velocity is changing. Now you see, when it comes at P, from P4, again it is coming closer and closer. Finally, we will say that it is a tangent is getting formed at this point. We are getting tangent. The graph is like this. And finally, we are getting tangent, right? This is the direction of velocity. Finally, this is the direction of velocity at P. So we can write velocity at P is this. This vector tells tangential direction at the point P tells the velocity at P. So on any curve, on any path is a curve. It may be straight line also, since it is in two dimension. The motion is in a plane. So we consider it a curvilinear path. At any point, if you want the instantaneous velocity, then direction will be along the tangent drawn at that point. So at this point, what is the direction of velocity? It is along the tangent drawn at the point P. And what is the tangent? This is the curve. So tangent means a line touching this point, and we are drawing a straight line. So this is the tangent at the point P. This is the tangent at the point P of the, this is the path of motion. So this is called the instantaneous velocity, right? This is the instantaneous direction. This is the direction of instantaneous velocity that I have shown over here. So I think geometrical interpretation of instantaneous velocity or simply velocity. Whenever we talk about the velocity of the moving object, then we are talking about the instantaneous velocity of the object at that particular instant. So this velocity part is clear. Now we will talk about the acceleration of the object when it is moving in a plane. As we have seen, the average velocity, in the same way we will go for average acceleration. What is acceleration as such? Acceleration means change in velocity, and velocity being a vector quantity, it changes either by magnitude or by change in direction or by the change in both magnitude and direction. So if change in velocity is there with time, then there will be acceleration, right? So how the acceleration is defined? The rate of change of velocity with respect to time is called the acceleration. So acceleration, right? So rate of change of velocity with respect to time is called acceleration. So according to definition we will write, suppose velocity change, this is the change in velocity. With respect to time, we have to find the rate. So delta t. This is called the average acceleration. This is called average acceleration. So delta v is known, or delta v upon delta t, that is equal to delta v, means we will write vxi plus vyj divided by delta t. So we will write delta vxi plus delta vyj upon delta t. Change in velocity. So here it is delta vx upon delta t I plus delta vy upon delta t j. Because this change we are talking about vx. What is the change over here and what is the change over here? So this is called average acceleration. So this we will write average acceleration. That is average acceleration, and this is equal to what? That is average acceleration along x-axis magnitude. So you will write ax average I plus ay average j, and that is a acceleration average. So average acceleration is average acceleration magnitude along x-axis and average acceleration magnitude along y-axis, and this is given in terms of I and j, that is the average acceleration.